Okay. Hi, everyone. Welcome to our next presentation. So next up, we have your first data science competition with John Steves, and I'm going to pass it over to John.
Hey everyone, I'm John. I'm a third-year computer science student, and I really like to practice data science in my spare time. So I guess how this talk is going to go today is I'm going to give you a quick presentation on what data science is, what data science competitions are, and then we're going to do a data science competition. We're just going to do that. So let's start with this. What is a data scientist? The common joke is that a data scientist is a programmer who's just bad at stats. But what is a data scientist? There's a lot of skills that go with it. Are they programmers? Are they analysts? To answer that, we have to answer what is data science. So data science is the extraction of insight from often large and unstructured sets of data using modern computing methods. That's pretty broad. I thought I would show this to you guys. I thought this was funny when looking up what data science is. The second search result up there is data science is the sexiest job. That's real. That's a screenshot I took when researching this. That actually links to an article by the Harvard Business Review, and what they're talking about is it's the sexiest job because of the job prospects, and they pay so well. So what kind of skills do you need for data science? Well, you need to know how to do programming, statistics, and you need a lot of knowledge on the actual subject matter itself. If you're reviewing COVID-19 data, right, to review spreads, it's really helpful if you understand the fundamentals of the virus, or else you're just kind of crunching numbers. Some skills that are going to be involved also are machine learning and research. So I really think that data science is kind of just storytelling, right? So I thought I would storytelling with numbers. So I thought I would give a quick recipe for storytelling with data. So there's many parts of data science. So the first one, of course, is coding. Because you're going through such large data sets, because you're going through such, you're reviewing data points that might not necessarily be related to like upon your initial analysis. You're going to have to comb through this data really well. So the first thing there is feature engineering. So feature engineering is taking data points and basically creating new features with it. So for example, let's say we have, I don't know, 2 data points, like you'll have, let's say renovation, right? I was reviewing housing data. Let's say what happened when, let's say the house had its first renovation in I don't know, 1950, and a second renovation in 2000. Well, that's a lot of data that's really related. So we might want to make a single variable for that, a new column for that. And we're going to basically take both of those two columns, two data points, or combine them into one. The next thing is data cleaning. Data cleaning is really important. Again, because you're doing it en masse, you can't really comb through it with a spreadsheet. It's kind of difficult. So you're going to be using modern tools to analyze the data and then find null values, outliers, all of that, so that you can have good data. There's this expression called garbage in, garbage out when dealing with machine learning and data science. So if you put in really bad data, you're going to have really bad results. It's kind of simple like that. So that's really important. Machine learning. I think Carleton AI touched on that recently. That's a huge part of it. At the end of your data science, at the end of a competition, you're going to be making a model, and what you're going to be doing is you're going to be predicting. You're going to have test data, and you're going to make predictions on that model. So that's very important, and there's all kinds of different machine learning methods that we can go over. I think what's incredibly important and is often glossed over is communication. Writing and data visualizations are incredibly powerful. The insights that you get are worth not that you make from your machine learning models and your analysis are worth nothing if you can't convey them. If you can't convey the significance of your insights, it's worth nothing. So data visualization is incredibly important. I always make the joke that the best data science are the ones with the most colorful graphs. That data visualization is just incredibly important. And then knowledge of the subject, like I went over. So today we're going to be looking at a data science competition hosted on Kaggle. Kegel is a website owned by Google, and it hosts various data competitions. It has over 500,000 active members. The data science competitions are anywhere from a contract that a company puts out, and it's for money, and it'll be like 3 months. Basically, you put a team together, and you basically make a model that they will use on their website. A good example was Home Depot wanted better search results on their website. So they put out a $40,000 contract on Kaggle, and they had this 3-month competition. They wanted the best model, and the winner got $40,000. So what happens is it's going to create a collaborative ecosystem. There's all kinds of notebooks that are uploaded on Kaggle all the time. There's all kinds of discussions that take place. It's a really great place to learn data science and really great place to learn the fundamentals of really how to analyze data. There's 16 practical courses on Kaggle, and they're all free. And then there's embedded notebooks. If you want to follow along, just go to Kaggle and then go to their notebooks, and you can actually write code and run it, and then save it to the website. So the process that we're going to go through today, and this is really the data science process. It's you retrieve the data. So whether that's you are going out by yourself and going to the Government of Canada website and grabbing data from there, or web scraping from YouTube, or whatever, or maybe just taking metrics from a website that you have. Retrieving the data is always the first step. Once you have retrieved and consolidated the data, you have to clean the data. Again, garbage in, garbage out. And then we get into this nice pattern of analyze the data and training a model. And you're basically just going to keep doing that until you're satisfied with your model, until you think you have great predictions, and then you're going to submit those predictions. Now, with Kaggle, they actually oftentimes will give you an immediate score. So you can then take how you scored, look at the discussion forums, look at discussion code, and then go back to your analysis, maybe change that, maybe change your model, and repeat the process again. This is really, there's a lot of trial and error that goes into this. And I'm very new to this, so I've experienced a lot of that. So here are some really popular tools, and we'll be using all of these today. So Pandas is a data frame. Pandas data frame basically gives you C-like speeds in Python. for processing data. It's incredibly fast, incredibly useful. It has so much functionality. You can write to SQL. You can fetch from SQL databases with Pandas. It's incredible for data analysis. We're also going to use Seaborn. Seaborn is great for data visualization. It actually uses Pandas as a dependency, so they go together quite nicely. Jupyter Notebooks is an IPython environment. So that's kind of like you have, instead of like in VS Code where you run all of your Python at the same time, you can actually run little pieces of it, and it will save the variables in the environment appropriately. And it's going to make it, I'll show you, it'll make it much easier to try things out in. And then finally, scikit-learn. Scikit-learn is a machine learning, also kind of data model making package. It's going to have a lot of important things, and it has, other than machine learning methods, it has metrics built into it, and it also has things like train test split, which really help you train your model. It's going to be really important. If you want to install any of these, it's quite easy. It's just a pip install. If you've taken first year computer science 1405, you probably have pip already installed. That's the Python package installer, I think, and it's quite easy. So I think let's just get to the demonstration that I have for you. Good. I want to show you guys this. So this is the Kaggle competition's website. So as you can see, we have all of these contracts, all of these competitions that are for lots of money, $160,000, $150,000. So if you're in a team of 3, you get $50,000 if you win this competition. Again, some of them want you to upload a model, some of them just want you to upload predictions. We're going to start with this one here today. It's called Titanic Machine Learning from Disaster. It's their first data set, and it's recommended for beginners. And I think everyone should take a look. There's discussion forums and code, like I've mentioned, and it's really great for beginners. So for this demonstration, what we do is we download the data, and it's just a CSV file. And then we stare at the data. I'm going to actually stare at the data using the, in this window, though, because it'll be easier, because there's clear visualizations at the top of it. So we have, I think, 12 variables, 1, 2, 3, 4, 5, 10 different columns here. So a survival, passenger class, sex, age, siblings on board, number of parents parents, number of children on board, the ticket number, the fare, the cabin the passenger stayed in, and the port of embarkment. What we're going to be doing with this data set is fairly simple. We're going to be using all of these variables, all of these features, to predict if a passenger survived or not in the Titanic disaster. So they split the data quite nicely for us, and we're going to take a look at it. Right. All right. So let's start with this. So what you normally would do is you would download your data. Here it is, train data, and then you're going to have test data. So I want to show you the difference here. So the training data is going to have the target class included. Today our target is survived or not. Did this passenger survive? Did it not survive? And the test data simply doesn't have the target. It's the rest of the data, but not the target. So any feature engineering you do, any data cleaning you do, you're going to have to do that on the same, you have to do that same process on the test data. This one? Yeah, okay. All right, so let's start by importing our libraries. All right. So what we're doing here is we're taking our CSV data and we're putting it into our data frame. And then I'm just showing the top. Pandas data frame has a ton of little functions that you can actually link together, and that will be useful later. Yeah, so I guess we'll start with some quick analysis of the data. So As we can see here, there's 189 entries. And if we go through each one of these, we just look at the type and see if it corresponds to what we think it is. So, int, string, which is represented by an object. Sex is male or female. Age is a float. Siblings on board. Parents, children, something like that. A number. An object. I'm not sure. I guess that's a string. It says object, but it must be a string. But what pops out here? We have kind of a lot of null values. We can't put null values in. We need values that a computer can process. So there's a few things that we're going to have to do here. Right now, a machine learning algorithm can't process things like a name, right? Well, it certainly won't. Certainly the one we're using will not be able to. Won't be able to process male, female. It doesn't know the difference. That's not a number. It won't be able to process. There's a lot of null values in Cabin. It won't be able to process that. So we're going to go over that. There's also a description of the data, if you care about that. So let's review that. So let's start with a heat map. The heat map is simply going to tell us what columns have null values in it and what columns don't. So as we can see here, the cabin has a lot of null values in it. So much so that I think it's only 204 not null values. I don't think there's much use in keeping cabin. Let's delete that. So from there, we have an age. Now, this is kind of feature engineering, kind of data cleaning. Not all the age values are in here, but I want you to think about the Titanic. Who survived on the Titanic? We always heard this. We always heard women and children first, right? Women and children. So age must be a factor in who survived the Titanic, because that's clearly, like, of the expression that we know. That's clearly one of the factors. So I think it's really important that we actually find a way to keep this column here. Let's keep going here. So I think what we're going to do is we're going to try and guess the age of each passenger that has a null value, and while keeping the values that are already there, that are already good. So we're going to make a function called guess the age. And what we're going to do is we're going to use a group by object that is made from the data frame. We're going to take the means, and then we are going to take the average age of each passenger each passenger class. And then what we're going to do is we're going to input that into this function for each column, and then it's just going to return the appropriately hard-coded age based off of the passenger class. So let's try that. All right, let's take a look here. Actually, I don't think there's any null values to show at the beginning, is there? Or, yeah. But maybe I'll show you this. Right. Okay, well, that looks much better, right? We have basically all of these columns lining up saying that that's a null value. We've eliminated all of the null values. I think that Embarked has a couple. Embarked might have a few. Let's see if we can work our way around that. Another thing we're going to have to do while cleaning the data is changing this field, the field of the person's gender, the person's sex, from a string, male or female, to some kind of dummy variable, 0 or 1. Now, there's no point in having, if you use Pandas dummies, what it's going to return, it's going to return a data frame of 0 or 1. So that's male 0 or 1 and then female 0 or 1. We don't need both. We only need one, actually. So that's what I think we'll do. Here, I'll show you. Right, it's going to return that. We don't need both. We just need one. Clearly, if you're, as we'll see, I'm going to hypothesize, and I think I'll show you down here. If you're a female, the chance of you surviving the Titanic is going to be greater than if you're a male. So we want variables that are going to have a positive correlation, not a negative correlation. So I think what we're going to do is we're going to take the male column and the female column, and then we're going to add that to sex. So that is, if they are female, if the sex is 1, then they're female. If it's 0, then they're male. Let's do that. Let's look at it, a heat map correlation. Now that we have more numerical variables, we can do that. Okay, so here we are, survived. So this is just a correlation matrix. Which I don't know if you guys have taken stats or not, but it's basically just, can one variable explain the movements of another variable, or do these two variables move together? So we don't have a ton of really strong values in any of the data, but we do have 0.54 when it comes to person's sex and if they survived or not. Okay, so that's lighting up there for us. So we should keep those. All right, here's what I want to show you guys. This is a scatter plot with the where we're charting age, passenger's fare, and the hue is going to be if they survived or not. Okay, so I think it's fair to say that fare is important, right? The richer people got off the boat. I mean, I've seen the movie Titanic, and then the there's clearly a cluster of people here who have low fare. They maybe they're stowaways, maybe they didn't pay anything, who did not survive. And then we can see down here there's a cluster who did survive, who, although their fare was incredibly low, their age is pretty low too. Okay, so these are really important to have. Let's do a count plot. Okay, right. So let's just look at that for a minute. This is just further, I guess, further visualization about how sex is going to be an important variable if the person was male or female, or it was identified as male or female. So let's start getting into making the model. Running out of time, I think. So we're going to import 3 things: train, test, split, we're going to import some metrics. I'll tell you what those are later. And then we're going to import a linear regression, a logistic regression linear model. So let's split the data. So first off, oh, that's in the wrong order. First off, what we're doing here is we're taking our data, and then we're taking our target class right there. And what we're going to do is split the data, and 20% of it is going to be for the testing. This is really important that we don't put too much of the data in any one, in testing or in training, because what happens is you can put too little test data, training data into the figure, and then it's not going to be, it's just not enough data. Or you can put way too much. Let's say we put 95% into training, we're going to overfit the model. And then suddenly when we put in new test data, like we're going to do at the end, it's going to come off really bad. Let's just quickly review. I just really want to show this. So as we've established already, age and fare are really important variables here. What's also really important is sex. So let's just make 2 graphs. So I think these are going to be our 3 variables: age, fare, and sex. So as we can see here, overall, women survived more and men died more. And the trend seems to persist with the other 2 variables. That is age. See, young people, young men, children survive. And then fare, right? Rich people lived, to put it simply. So let's import the model again. So then again, our columns are going to be these ones. All right, let's do train, test, split. I realized that the one above me, I forgot to drop survived. That's really important. I dropped that. We don't want to give that indicator away when training the model. Train the model. So I just want to show you, this is what our testing data is going to look like. Our testing data is going to look like. It's just these 3 variables that we've narrowed it down to. And let's predict, right? So what do predictions look like? That's what they look like. It's a list of 0 or 1. then we're going to take out the confusion matrix, right? So now we've done our model, by the way. That was the big machine learning AI. It's just a logistic regression, so it's not that certainly not as complicated as you'll learn in Introduction to AI, but something. This is the confusion matrix. This is really important. For classification, this is kind of your bread and butter. So we have what we predicted and what the true class is. So we want a lot of the green and as little of the red as possible, basically. So let's review, right? It looks like we did all right. Okay, so our F1 score is 80. So that means our precision is 77, recall is 83. Now, honestly, I kind of forget what's the difference between, or sorry, what precision and recall correlate to in the columns. But I will say that our positive predictive score just be like 82%, right? Okay, so that's our recall, I guess. Okay, so this model's okay for predicting who died. For predicting who survived, it's only about 69%. The overall accuracy is 75. Okay, let's just put that in context here. Actually, let's just describe the data. Oh, spelling's really important in this too. Okay, so the overall mean is 38%. We can kind of guess that about 38% of the people survived. That's a really lazy way of doing it, but that's the way I did it. Okay, that's not terrible. All right, so now let's use our test data and let's actually import that. And then we're going to put it through our model, and then we're going to submit some predictions, see how it goes, and complete the competition. So I wanted to bring this up because when going through this before, I noticed that not all data is equal. So a key variable, test data? Key variable was the fair, and the problem here is that fair is actually missing one. I don't know why they would do that to us, just make data that provide us testing data that just isn't valid, but I guess we have to fix that. So what we're going to do is we're going to make another function called guessFair. We're going to go through our old functions of cleaning the data. We're going to use all that, including dropping the cabin, columns, predicting the data. We're going to make our predictions. Here are our predictions. Now we're going to make a new data frame with two columns, survived and passenger ID. We're going to take our data frame. We're going to grab the passenger ID, grab the survived, if they survived or not, and then we are going to put that to CSV, right? Just a new CSV file. So dev day predictions, here it is, right? So then we can submit our predictions right here. All right. For dev day. Dev day demo, I'll call it, to make that submission. And then we can see how we did. Now it takes a minute. Let's see. So our score was kind of on par what we thought it was going to be, 0.75. So we got about 75% of it correct. So then we can always check other things. We can go back to our model, discuss other features. I know there's definitely other ones out there. I know that you could probably look at a few things like, I don't know, the person's title, maybe make a feature for the person's title, maybe what their cabin was, what their ticket was, maybe where they embarked from. Maybe you can include the passenger class in it itself. But yes, that's all for now. I guess I think we did pretty well. I've been talking for a while. Does anyone have any questions? I don't know if that's a thing right now. but yeah, that's it for the talk. So congratulations, everyone. We got a .75 score.
Awesome. Thanks, John. That was great.
Oh, thank you.
The one question I have, honestly, we are like right at time, so
Yep. Sorry
I
about
will
that.
say I don't know if Forrest decided to move the next workshop forward by 15 minutes or not, but the one question I did have for you was you mentioned like early on you were talking about, like pandas. You mentioned that pandas was like as fast as C. Can you explain that? Like, is that like a real thing? Like, I didn't know that. Is like, how does that how does that like how does that work? You know what I mean? Like,
Yeah.
how is that
So
possible?
it's not as fast as C. It will never be as fast as C.
Mm-hmm.
But the saying is C like speeds.
Mm-hmm.
It's basically, from what I understand, it's developed in C, and it just uses clever indexing in a way that just it's going to make it faster than putting like a bunch of lists together. I know
Mm-hmm.
that if you want to go to pydata.org, pydata.org, there's a lot of really good lectures, and surprisingly, a lot of traders from banks actually use PyData to process it.
Mm-hmm.
So it's process their data. So it's pretty fast. Yeah. So,
Okay.
but I can't really answer the technical of that. Sorry.
Mm-hmm. Yeah, no, that's all good. Yeah, I don't know anything about it either, honestly.
Yeah.
Um,
All right. I guess if there's no more questions, I think we'll leave it there. But yeah. All right. Well, I guess yeah. Thank you for coming.
all right, awesome. Thanks for giving a talk.
Thank you.
All right, I'm gonna end the broadcast.